All right, great. So one question, maybe, Rahul, kind of the same question that we first asked Akihiro is, so any kind of recommendations that you would have in terms of either the CHIUW language or the compiler that would, that you're like, oh man, if it only had X, it would have made what I was doing so much easier, or, kind of the next steps, or what do you kind of see as something that would help you in the research work you're doing?
Um, so, like at the start of this project, I thought that if Chapel had um, the ability to um, rewrite your code, so like redefine, native constructs like C++ has using macros, that would have made um, this project like a whole like exponentially smaller and like both in time and the code base. Um, but of course, then we moved on to like we looked into multiple different approaches, which included like OpenACC directives, OpenCL. Now we've moved to LLVM backends.
Okay. And in terms of kind of next steps, what do you see as it's kind of like the most challenging thing ahead for you in?
Um, get something that a user can easily use. So the problem is currently with our current implementation, we haven't been able to implement a locale model. So
Yeah.
The conditional test case that I mentioned in the presentation, we currently have to hard code it into the compiler and then check which parameters are being passed. So once we have a locale model working, we can users can try it out, tell us about bugs, and we can also talk about different performance optimizations. And as Dr. Hayashi mentioned in the previous talk, with native GPU support, its optimizations are a bit hard.
Right. Yeah. Got a couple questions online. First one from Brian is, you disallowed many features of Chapel. Do you have a sense of which of those might have the most impact on practical uses of your library?
So the idea behind like creating a subset of Chapel is to get a minimal, as a like minimal subset going, so that like we have robustness. We like someone can just go look up the documentation for that and write a code and not have unexpected behavior.
Right.
And so we tried only the smallest features that we could, and of course it can be expanded later on.
Okay, nice. And then Michael Ferguson asks, is your work available as open source?
It's private right now, but can be made public. The OpenCL one is I think it currently is public, but once again, it's like you have to go fiddle with the compiler and hard code values to make it work.
Okay, right. All right. So if people wanted to get access to it, they could reach out to you, though?
Certainly, yes.
Yeah, okay, great. And then David Wanacott asks, I have a vague memory of a C++ library that did loop optimization by building a representation of a sequence of array computations, and then when forced to evaluate, it would do things like loop fusion. My apologies that I can't find the citation. Hopefully I'm just remembering a dream. Are you familiar with this work, or does anyone else in the room have the citation?
I don't think I've seen that work before. So GP Arrays was just the toy project that I was sitting with Josh, who's unfortunately not here today, and we were just spitting ideas, going through and forth, and this just came up, and we tried a toy implementation and worked out nicely. We wrapped arrays as objects inside records, and on each operation, we just pass on an intermediate representation, and it's evaluated from left to right.
Right, yeah. Ian says the C++ library sounds like a lot of things, sounds very halide. So I don't, and then David saying maybe he was remembering it as halide. So anyway, great.
Okay, I'll certainly check it out.
Yeah, 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 yeah.
I didn't type it in, but I've got a quick question. This goes back to, I think it's a little bit related to what you were saying about the locale model, and a little bit related to the flowchart you showed on one of your slides that kind of shows different ways to generate code and such.
Yep.
I seem to remember you asking a question on the online chat quite a while ago. Kind of, you were trying to get a sense of, this is sort of something I wonder about a lot in Chapel, and don't have a clear answer to. So I'm hoping I can ask the question clearly, which is, in general, we talk about like on the CPU locale or on the GPU locale, do such and such. But of course, if you're doing that in a data-driven manner and you say, run this wherever array X is, then statically it can be really hard to determine whether that's a CPU locale or a GPU locale or memory. And I was curious whether through the work you've done and your experiences so far, do you have thoughts about the degree to which the compiler should be determining like, this is going to run on the CPU versus the GPU versus generating both versions and then dynamically selecting between them based on what it finds out about where X lives dynamically?
That's an interesting one. So how I think of it is the user specifically, the user explicitly specifies what thing it should execute on. But Josh had some other ideas about it, including some of the work done by Dr. Hayashi and others at Rice includes splitting up the work and distributing it onto different devices. And I think that can be used for a data parallel approach.
Okay, cool, thanks. Yeah, I feel like that's a problem that is ahead of us and kind of we've been wrestling with slowly for many years. And I think it's going to hit us as we go to this GPU world more and more within the core team. So thanks very much for your thoughts there.
Right.
Nice. So this concludes our section on GPUs. I'd like to thank both Rahul and Akihiro again for their talks and being here today. Thank you very much, and I think we have a break up next.